Okay, so we're trying to find the Legendre symbol of 182. So I've broken 182 down as 2 times 7 times 13. And for the Legendre symbol of 2, with respect to any prime, I have my nice condition modulo 8. But it turns out that 421 is congruent to 5 modulo 8. Right? So that means there's a minus sign that I have to put in here. So let me put in a minus sign here. So this is going to be minus the Legendre symbol of 7 relative to 421 and 13 relative to 421. Okay, what would you suggest that I do next? Use the quadratic reciprocity law. I forgot to mention this is the quadratic reciprocity law, the QR law, quadratic reciprocity. So modulo 4 is the 421 going to be congruent to 1 or 3 mod 4? It's 1 mod 4, right? So it's 1 mod 4, so that means that when you flip the first one over, there's no sign change. And the second one, same way, no sign change. You can actually flip both of them over with no sign change at all. So that's what you want to do. Okay? Flip those both over. Now you can reduce the 421. I'm going to use this bottom fact here, right? I can reduce the 421 modulo 7 and modulo 13. Okay, so let's try it. What is 421 modulo 7? Oh, that's 7. That's 1, exactly, because that goes in there exactly 60 times with a remainder of 1. So 421 reduces to negative of the Legendre symbol of 1 with respect to 7. And how about mod 13? It's 3 times, the remainder of 3, 2, looks like it's a remainder of 5, is that right? Okay, so we get 5 with respect to 13 here. Okay, what's the Legendre symbol of 1 relative to anything? Positive 1, okay, 1 is always a perfect square. So we have minus the Legendre symbol of 5 with respect to 13. Let's flip this over again, okay? So you could just calculate all of the perfect squares in mod 13 at this point, okay? And see whether 5 is one of them or not. But this is so easy to flip over. When I flip this over, it does not cost me a sign change because they're both congruent to 1 mod 4. And that just becomes the negative of the Legendre symbol of 3 with respect to 5. Once again, we can flip that right back over again. I'm just going to really go all the way to the end here. And there's no sign change when I do that because 5 is congruent to 1 mod 4. And then I reduce the 5 to a 2. You can't flip that one over because you can't put a 2 on the bottom. But now you go back to the condition for 2 with respect to P. P in this case is congruent to 3. It is 3. Therefore it is congruent to 3 mod 8. So there is a sign change and this becomes a plus 1. Okay, at the end of the day. Be sure to show all of your work, guys. I'm not going to give you any credit if you haven't answered without work on this because you have a 50-50 chance. I'm kidding, you're right. Okay, is everybody good with that? Okay, so I just wanted to review that. Make sure you can do those kind of problems. Let's do another one. Yeah, we're flying through my problems here. This is great. About halfway through them already. Okay, let's do number 5. Find all solutions, if any, to the following. So we're going to have 3 parts to this. We're going to do 3 different problems here. The first one is actually a system. X is congruent to 5 modulo 8, and X is congruent to 11 modulo 18. Okay. Can I use the CRT on this? You can't because the mods are not relatively prime to each other here, right? Whenever the mods are not relatively prime to each other, we run into a question if there's even a solution at all. Okay? So what I'm going to do is remind you what the condition is. there will be a solution to this. So let me just call this star, right? So star has a solution if and only if the condition is that the GCD of these two mods, which of course at this point is not 1, it's actually going to be 2, it has to divide the difference of the numbers that are here. So if you take, 5 minus 11, okay? So in this case, that's just 2 dividing -6, and that is a yes. So there will be a solution to this. There will be a solution to this. And the solution, so we get, I'll just remind you again, we get a unique solution modulo what? Does anybody remember what the mod is for the unique solution to this? The LCM, exactly. The least common multiple of 8 and 18. By the way, what's the best way to find the least common multiple of two numbers?
Probably divided by GCD.
Use the GCD, right? Exactly. What you do is you remember that the LCM times the GCD equals the product of the two numbers. So if you take the product of these two numbers and divide by the GCD, which is 2, you'll get the LCM. So the LCM of 8 with 18, as it turns out, then that's going to be 8 times 18 over 2, which is 72. So we're going to be getting solutions in mod 72. Okay? When you're writing down your answers to problems in a number theory class, and it's a congruence equation, make sure the mod is clear. Okay? If you just write down at the end of some calculation, if this is your answer on your test, x congruent to 10, I don't know, I have no idea what that is, right? Is that mod 17? Is that mod 55? Is that mod 102? Depending on what mod it is, this could be a lot of different things. So please, show your work very carefully, write down the mod that your calculations are being done in. So in this case, it's going to be mod 72. Okay. Now, does anybody remember how to get the solutions to this system of congruences in this case? Does anybody remember the way we do that? Okay, I'm going to remind you. Essentially, you're going to write the GCD. You're going to, once again, figure out how to write the GCD as a linear combination of the 8 and the 18. So let's start with that. I'm going to take 18. I'm going to divide it by 8. It goes in 2 times with a remainder of 2. That's the GCD right there. Okay, so we're already done. 2 is equal to, it's going to be 18 times 1 plus 8 times -2. So I'm just going to put it into that format like that. Okay, so you just simply want to do that. And then, your A minus B is a multiple of that. So what you do is you scale this equation up by whatever that multiple is. So 2 goes into -6, right? -3 times. So I'm going to multiply through by -3. That's going to give me -6. So this is 18 times -3 plus 8 times 6. Okay, so you end up with that.